So today we'll be working on this question of coordinate geometry, which requires concept of midpoint, slope of parallel lines, gradient in general, and finding length of a line using distance formula. So let's see how to go about it. First and the foremost thing is reading the question carefully. Let's read the question. For the points A minus 1, 1, B 1, 5, and C 5, 1, M is the midpoint of AB and N is the midpoint of BC. Show that MN is parallel to AC. MN is half the length of AC. So let's have a pictorial representation of this first. Let's say I'm drawing AB and it is a rough diagram, not to scale. So coordinates of A I'm going to write here minus 1, 1. Coordinates of B 1, 5. So I've got A and B. Now I'm going to draw C. Coordinates of C are 5, 1. Now the next part of the question says M is the midpoint of AB. N is the midpoint of BC. So I'm going to get my M somewhere here roughly. I don't know the coordinates yet. And N is the midpoint of BC, and I don't know the coordinates of N. This is our pictorial representation. I'm going to use midpoint formula to get the coordinates of M and N. Let's see how to do that. So for that, first of all, I need to know midpoint formula. Midpoint formula is so if there are two coordinates x1, y1, x2, y2, then the midpoint of these two coordinates or points will be x1 plus x2 upon 2, y1 plus y2 upon 2. This is our midpoint formula. From where x1, y1 and x2, y2 will come from in our question. So we are supposed to find this M and N. We'll deal with first M. M is the midpoint of AB. Our x1, y1 could be this. Or the other one, I can take x1, y1. It's my wish. So I'm taking this as x1, y1. And I'm taking this as x2, y2. Now I'm going to apply midpoint formula here. So I'll get x1 plus x2 by 2, which will be minus 1 plus 1 by 2, then 1 plus 5 by 2. This is x1, y1 and this is x2, y2, and I applied midpoint formula. So the first one would be 0 upon 2, which is 0. This will be 6 upon 2, which is 3. So I got the coordinates of M. It is 0, 3. Using the same method, I will find coordinates of N. To move forward from here, to get the value of N, which is the midpoint of BC, I'm going to use the second side of my board, which is here. So now I'm going to work on finding the coordinates of N. So let's refer to this again. Coordinates of B, I have 1, 5. And coordinates of C, we have 5, 1. N is the midpoint of this. We don't know the coordinates, as you can see in the original drawing. So now let's find the value of N using the same concept and same midpoint formula. Our midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So N will be 1 plus 5 divided by 2, This will be x1 plus x2 divided by 2. Next, it will be y1 plus y2 divided by 2. So y1 is this, y2 is this, 5 plus 1 divided by 2. We will simplify it further. So we'll get 6 upon 2, 6 upon 2 for both, which is 3 comma 3. So now I have coordinates of n as well. And we have the coordinates of m and n. So once we get the coordinates of m and n, which is the midpoint of AB and BC, I have to show that MN is parallel to AC. Seeing that pictorially, I'm going to just join this, and remember it's a rough diagram. So here I have to show MN is parallel to AC. You can show that MN is parallel to AC if their slopes are same. So now I have to find the gradient of MN and gradient of AC. So let's find it. So for the A part, I have to show that MN is parallel to AC. So for that, I'm going to find M stands for gradient or slope. Gradient of Mn first. Gradient formula is M stands for gradient or slope. It is y2 minus y1 upon x2 minus x1. Gradient is also rise over run. So the y coordinate should be coming in the numerator and x coordinate, which is run, should be in the denominator. Rise shows the vertical movement and run shows the horizontal movement. So using this formula, we're going to find gradient of Mn. I have the coordinates of n here already, and I have to just note down the coordinates of m. Coordinate of m when we solved initially was 0, comma 3. So our m is 0, 3, and n is on the same page here, which is 3, comma 3. I'll now use this formula for this. This is x1, y1. This is x1, y1, and this is x2, y2. So y2 minus y1 will be 3 minus 3. This is y2 and this is y1. You can take any one coordinate as x1, y1 and the other one as x2, y2. So this will be 3 minus 3 upon x2 minus x1, which is 3 minus 0. I'm getting 0 upon 3. 0 upon any number gives me 0. I got the gradient of Mn. Now I'm going to find gradient of AC using the same method. For this, I will require the coordinates of A and C. So from the original question, if you notice, coordinates of A is minus 1, 1, and C is 5, 1. And we have C on the same page here also for our reference. So now gradient of AC will be, again using the same formula, y2 minus y1 upon x2 minus x1. So it will be 1 minus 1 upon 5 minus of minus 1. Because my x1 is negative, I would like to keep it inside the bracket, all negative numbers. So 0 upon 6, again 0 upon any number is always 0. So now you can see that gradient of Mn is same as gradient of AC. So you can write the final answer stating as gradient of Mn, small m stands for gradient or slope, is equal to gradient of AC. Therefore, Mn is parallel to AC, hence proved. We are done with the first part of the question. To find the length of Mn, I will write down the coordinates of M and N. Coordinates of M are 0, 3. Coordinates of N are 3, 3. We found it. These were our midpoints of the first part. So let's find the length of Mn using the distance formula. D is equal to square root of x1 minus x2 whole square plus y1 minus y2 whole square. The same formula can also be written like this: x2 minus x1 whole square plus y2 minus y1 whole square. Whether you take x1 minus x2 or x2 minus x1, it doesn't matter because eventually you're squaring it out. And even if you get a negative number inside the bracket, after squaring it, it will become positive. To find the length of Mn, I will take this coordinate as x1, y1 and this one as x2, y2. You can take the other way around, whatever suits you. I will plug in x1, y1 and x2, y2 in this formula. I will get length of Mn is equal to square root of x2 minus x1 square. This is my x2 and this is x1. So 3 minus 0 whole square plus 3 minus 3 whole square. Let's solve it further. I will get square root of 3 square plus 0 square, which is equal to square root of 9, and this is equal to 3 units. Let's find the length of AC after this. So to find the length of AC, I need to know the coordinates of AC, which I can write from the main question. A was minus 1, 1, C was 5, 1. So I have the coordinates of A and C. Using the distance formula and same method which I used for Mn, I'm going to get the length of AC. This is going to be x2 minus x1, and I'll keep the negative number inside the bracket. So negative 1 you can see I've put inside the bracket, and I'll use another bracket here, plus this is y2 and this is y1. So y2 minus y1 square. Solve it further. You will get 5 plus 1 whole square, which is 6 square. This negative here will become positive, plus 0 square. So this will be square root of 36 and this will be 6 units. So now let's observe the length of AC and Mn, what we got just now. So length of Mn is 3 units. Length of AC is 6 units. So clearly we can see that Mn is half the length of AC. Hence proved. As AC is 6, which is twice Mn, or Mn is 3, which is half AC. So this question had two parts. First part was show that Mn is parallel to AC. For that we used the concept of gradient. We proved that the gradients are same. That is why the two lines are parallel. Second part was about the lengths of Mn and AC. For this we use the distance formula, and we have seen that Mn is half the length of AC. So both the parts are done for this particular question.